In this presentation, we will try to find out the answer of the question, what is parity? I think this word parity is something that you are already familiar with, because it is something which very often repeated in the digital electronics course. So let's move to it. It is concept to detect the errors. Error detection and its elimination is a very vast field in the electronics, and the engineers and scientists constantly work on this field, because we want the signal transmitted as it is at the receiver's end. We do not want any distorted signal at the receiver's end. So the parity is one way to detect the errors, and it is only for the detection of a single bit error. Okay, a single bit error is detected by it. If there is an error in the 2 or more bits, then definitely the parity is not going to tell you about the error, because it is only for a single bit error. Now I will explain you these two things in a real quick time, and let's move to it. Let's say this is our receiver's end. Okay, this one is our receiver end, Rx, and the yellow one is our transmitter end. This is our transmitter's end, and a signal is transmitted from, let's do it in different color. A signal is transmitted from the transmitter to receiver. Generally we make transmitter on this side, but I made it, so there's no problem. A signal is transmitted through this channel from the transmitter and then received by the receiver. Let's say the signal is a 4-bit signal. Okay, and we know that in this channel there are so many factors that are there to affect this transmitted signal. So there are noises involved, and because of that noise, maybe some bits changes from 0 to 1 or 1 to 0. We can say that it becomes high to low or low to high, and if that happens, we can detect it by the parity. So what is this parity? This parity is actually an extra bit. Let me write it down. It is an extra bit that we send with the bit stream. So we send a bit stream, which is this 4-bit signal, and also an extra bit, and this extra bit tells us the total number of ones. Tells us the total number of ones in the transmitted signal. So what is the use of this total number of ones? So this is something we have to cover by one example, and let's say in this 4-bit signal, transmitted signal, we are having a single one. So let me write it down. 0 1 0 0. This is the transmitted signal, let's say. Now you can see the number of 1 in this bit stream is 1, which is of course odd, and if it was even, then we have to do the different operations. So depending upon this, there are two types of parity. The first one is your even parity, and the second one is your odd parity. Okay, now if we are talking about the even parity, so what will happen? An extra, this is our original transmitted signal, and there is an extra bit that will tell us about the total number of ones, and we call it as the parity bit. This is our transmitted signal, or you can say that original signal, and here we are having the parity bit. Okay, and whenever we are talking about the even parity and there is an odd number of 1 involved in the original signal, we will add a 1 here in the parity bit, or we will make the parity bit high to make the total number of 1 as even. Remember, the total number of 1 as even, because this is a bit confusing. People think that whenever there is a even ones in the original signal we will make the parity bit high, and that is actually we do in the odd parity. So what you have to remember, you have to remember that the overall in the overall signal the number of 1 should be even in case of even parity. Very simple. Let's take another example of this even parity. If the signal, the original signal was 1 1 0 0, so what you can see here, you can see that there are two ones, which means it is even number of ones. So whenever there is an even number of ones already, in case of even parity we just make the parity bit 0, because what we want at the end of the day, we want the number of 1 as even in case of even parity. Similarly, if we talk about the odd parity, this was the case of even parity, and now we will talk about the odd parity, and we will take one example of a 4-bit original signal. The same example, let's say 0 1 0 0. Okay, this is our original signal, and here we are having the parity bit. So in case of odd, we want the overall signal including this parity bit odd number of 1. So here we are already having the odd number of 1, so we will add just 0 as the parity bit. And let's take this one. In case of odd parity 1 1 0 0, here we can see that the number of 1 is even, and in odd parity we want the total number of 1 as odd, so we will add 1 here. So this is very simple, but how we are going to detect the error now? We just right now we know that what we have to do in the parity, we just add another bit stream, or you can say that the extra bit, not a bit stream, extra bit, which tells us about the total number of ones, whether they are even or odd. Now how we are going to use this information for the error detection? Let's say in this particular case, a noise has been added. A noise has been added in the channel, and because of that noise, let's say this last 0, that is our LSB, becomes 1, which was actually 0 in the previous case, and this parity is set at the transmitter's end, and this parity is already set as 1 depending upon the signal 0 1 0 0, but now because of the noise the last 0 is now 1. So we already know that it is the even parity. The transmitter end has to inform that the receiver end that we are sending the signal according to the even parity. So he will detect the signal and he will see that the parity bit is high, which tells us that there must be an odd number of 1 in the original signal. But what we are having here, we are having even number of 1. So definitely at the receiver end he will know that there is an error, in this particular signal. Okay, so this is how we detect error in the parity. I think this is clear to you.